Dear students, today we are going to discuss about the flight planning in aerial photogrammetric survey. As photogrammetric survey is a costly affair, huge money is required, huge expertise is required. So before taking the photograph, so flight planning is one of the essential tasks in aerial photogrammetry in order to reduce the wastage of labor, time, resources, and money. The different parameters to be considered during aerial photogrammetric planning is the flying height, that is the flying altitude, the height at which the aircraft is to be fly, then the focal length of the camera. Camera means aerial camera, which governs the flying altitude. Then size of the photograph, that is the dimensions of the photograph, that is whether it is a 22 by 22 centimeter or the 23 by 23 centimeter photograph. Then size of area or land to be photographed, either you know the area directly in square kilometer, or the area can be known in terms of the dimensions, that is the length and breadth of the area. So usually the area covered is a larger one. The dimension for the length is in kilometer. Dimension for the breadth of the area is also in kilometer. Then the alignment of flight line and the parallel flight line, that is the direction in which the flight is to be run, that is the aircraft is to be run. Then what percentage of the overlap is required, because which obviously governs the number of photographs, that is the percentage of the lateral overlap and the percentage of the longitudinal overlap. Then the number of photo in each flight line and overlap, scale of the flight map, ground speed of the aeroplane. You know that the speed of the aeroplane with respect to the ground is called as ground speed, and the speed of the aircraft in air is called as air speed. So what is the difference between the ground speed and air speed? So if the aircraft is moving with the speed of say 500 kilometers per hour and the headwind is blowing with a velocity of 50 kilometers per hour, then the airspeed will be 500 minus 50, that is the 450 kilometers per hour. Then the time interval of the successive photograph, that is the at what time the shutter of the aerial camera is to be open to capture the photograph of the terrain or the ground. So this is also called as the airbus distance, that is the distance between the two successive photographs will be depend on the time interval of the successive photographs. So how the vertical photograph is taken, you already aware of that. So the position of the camera at the exposure station is called as during the exposure is called an exposure station. This is the point in air or space. Then the height at which the aircraft is flying defines the flying height, that is the altitude at which the lens of the camera is mounted. Then the side overlap, adjacent flight strips, then the block of the photos of two or more side lapping strips. When you take the photograph, you have to decide that in which direction is the aircraft is to be run to capture the photographs of the terrain. So this is to be done during the flight planning very carefully. So aircraft is to be run in the desired direction, then it takes the turn and again realign itself in the same direction, and the number of runs are taken to cover the given area. So in the given slide, so that irregular shape indicates that area is to be covered, and that line indicates the flight lines, the number of flight lines. When each photograph is taken, you need the overlap in the direction of the flight, also in the direction perpendicular to the flight. So between the two successive exposures, the desired overlap is necessary. So uh, Point number one, that is the digits 1, 2, 3, 4 in the given figure indicates the position of the camera lens at the time of the exposure. It indicates the four successive photographs of the terrain are taken with a certain percentage of the overlap. So this figure clearly explains the percentage of the overlap in the direction of the flight. The overlap of the photograph in the direction of the flight line is called longitudinal overlap or forward overlap, or you may call it as a simply overlap. So nearly the percentage of the overlap in the direction of the flight, that is the longitudinal overlap, is about 55 to 65%. Then the percentage of the overlap direction perpendicular to the flight line is about 20 to 30%. So, or it may be taken as 15 to 35%. You need to decide the percentage of the overlap in the longitudinal direction or in the side direction, that is side lap in the lateral direction, because if the percentage of the overlap is more, then the number of photographs required to cover the given area will be more. So this figure explain the percent overlap, positions of the overlap in the lateral direction and in the longitudinal direction. So first figure indicates that is 30% overlap in the lateral direction, and the second figure gives the idea of the overlap in the longitudinal direction, which is about 60%. So the distance between the two successive exposure station is called as airbus distance. So distance between the two position of the camera lens in the air is the airbus distance. This figure explains the amount of the area or the percentage of the area covered by the single photograph. As I said, there are two kinds of the overlap: longitudinal overlap or the forward overlap. Usually the longitudinal overlap between the two successive photos is about 55 to 65%, and the lateral overlap or the side overlap is about 15% to 35%, that is overlap between the adjacent flight lines. Why we need this overlap? This overlap is necessary to tie the different prints together accurately. It is desirable that the principal point of each strip should appear on the edges of as many adjacent strips or as many adjacent photographs if as possible. Then for the arrangement of the mosaics, mosaics means if you arrange the photograph by excluding the overlap portion, if there are 10 photographs, if you arrange the photographs excluding the overlap, then you will get the nature of the ground, idea of the ground. Then that arrangement is called as mosaics. Then to remove the errors due to distortion, displacement and the tilt. Displacement means distortion due to the relief displacement, distortion due to the tilt, distortion due to the camera lens. Then in order to view this photograph under the mirror stereoscope, the overlap is necessary. Without overlap, it is not possible to get the three-dimensional view of the photograph under the mirror stereoscope, what you call as the fusion of the photograph. To avoid this aerial survey number of times, repeatedly conduct the same work, it is a costly work, it is not possible to repeat it again and again. Then in stereoscopic examination, objects can be viewed from more than one angle if sufficient overlap is provided. If the flight lines are not maintained straight and parallel, the gaps between the adjacent strips will be left. So these gaps can be avoided by having the overlap in the lateral direction. So the no portion of the ground is photographed, no portion of the ground is left unphotographed. Then the overlap is also necessary so that each portion of the ground is photographed 3 or 4 times, so any distorted photo can be rejected. That means if one of the photo is not clear, photo get distorted, maybe due to the lens position, maybe due to the relief displacement, maybe due to the any other reason, then that photo can be excluded from this study. Then once you get the idea about the flight planning, then you can easily find out the number of photographs required to cover the given area. If the area of the ground is given in directly in square kilometer, that means the dimension of the area is not given, length is not known, breadth is not known, the whole area is known directly in square kilometers, then the number of photographs necessary to cover a given area can be calculated. How these calculations are done? So let us say capital A represents the total area to be photographed, small l represents length of the photo in the direction of the flight, then the small w represents the width of photo normal to the direction of the flight, then s is the scale of the photograph. As you know, be careful at this point while using the numerical value of the scale. As you know that scale is the ratio of focal length of the camera to the flying height, that is f by h. As you know that scale can be represented in the different fashion, that is 1 centimeter is equal to several meters, or in the form of the rf, that is representative fraction 1 as to something. If the scale is 1 as to 100, 1 as to 1000, so 1 as to 1000 means the 1 centimeter on paper is equal to 1000 centimeters on ground. So this is in the form of the RF. The same scale can be written as 1 centimeter is equal to 100 meter. Okay, so that is here when you take the value of S, the S should be in meter. Then capital L represents the net ground distance corresponding to the L, that is the length of the photograph. Capital W, net ground width corresponding to the width of the photograph. This letter small a represents the net ground area covered by each photograph, that is a single photograph. Then P suffix L represent the percentage of the overlap in the direction of the flight, as this is about 55 to 65%, and P suffix W represent the percentage of the overlap in the direction perpendicular to the flight, what you call as the side lap or the lateral overlap, which is about 15 to 35%. Once this data is known, then you can easily find out the number of photographs necessary to give an area when the only area is given, the dimensions of the ground are not known to us. Since each photograph has a longitudinal lap, that is the forward overlap, say PL, the actual ground length in the direction, the actual ground length that is covered by each photograph is given by the equation capital L is equal to 1 minus PL into L into S. How these equations come? PL represents the forward overlap. Suppose the percentage of the overlap is 60%, then the value of the PL will be 0.6. That is the net ground covered by the single photograph will be only 0.4 of the length of the photograph. So 1 minus PL into length, that is the length of the photograph, and S is the scale of the photograph, that is 1 centimeter is equal to S meter. So using this equation you can find out the actual ground length covered by each photograph or the single photograph. Likewise, you can also find out the actual ground width covered by each photograph. Here we use the letter capital W letter is used to cover to denote the actual ground width covered by the single photograph. The capital W is equal to 1 minus P suffix W into W into S, where PW is the lateral overlap. If the lateral overlap is 20%, the value of the PW will be 0.2. So 1 minus 0.2, this is 0.8. W is the width of the photograph. This dimension will be in centimeter. Remember, be careful here. The length of the photograph is in centimeter and the width of the photograph is to be substituted in centimeter only, and the value of the S should be in meter. That means this much centimeter distance is covered by the photograph in the lateral direction. So this much distance on photo is equal to how much distance on the ground. So you are multiplying with this s in meter, so you will get the result in meter. Remember, the unit for the actual ground length covered by the each photograph will be in meter, and the unit for the actual ground width covered by the each photograph will be also in meter. For our convenience, later on you can convert it into the kilometer. So the ground area covered by each photograph, as the larger area is covered, okay, the actual ground area, the unit for the actual ground area is in square kilometer, correct? So the ground area covered by the each photograph will be capital L into W. So the total number of photographs required to cover the given area is equal to number of photographs is equal to total ground area to be photographed, that is capital A, divided by the net ground area covered by single photograph. So using this simple equation, you can find out the number of photographs required to cover the given area. Thank you.